You are going to want your calculators out, ladies and gentlemen. They'll be helpful. So we're doing the same thing we did yesterday, except we have rational functions instead of just polynomials, where we're trying to find where the function is positive and where the function is negative, greater than 0 and less than 0. So we have the same idea where we need to find those critical points. And except today, we're not just factoring like we could do yesterday. Today, we have rational functions. So you're going to see stuff like this where we are adding or subtracting two fractions. And what we need to get is a common denominator. So what do we need to multiply this first fraction by? Yeah, x plus 2 on top and bottom. And then what do we need to multiply the second fraction by? X minus 6 on top and bottom. That way we get that good common denominator. And I'm going to just leave my common denominator in a nice little bubble form. But the numerators, we have to distribute and combine like terms. So what do you get when you distribute the 5?
5x plus 10.
5x plus 10. And then be careful, we need to distribute a negative 3. So when you distribute the negative 3, it becomes negative 3x plus 18. Good. And then we can combine like terms. So we have 5x minus 3x is 2x, and 10 plus 18 is 28. Okay, and so this is what we want to get today. We're going to have a nice common denominator for our fraction. And so when we're in this rational fractional form, we need to find the critical points. And the critical points occur by looking for the zeros. Zeros come from the numerator. Okay, that's enough. And then the other critical points are where our function is undefined. And undefined comes from the denominators. So if you have this single fraction format, then that's pretty easy to go ahead and we'll find all those critical values. Now, graphically, rational functions are those L-shaped things. So it's a little more complicated. We're going to use our calculators to kind of help us out a little bit. But pretty much the same idea as yesterday. You will also need to look at example 7 to help you out with this last couple of problems. I did take a picture of it. It's posted on the class website. But so today, critical points. That's what we're looking for. So example 1. Solve the inequality. Solve the inequality means find the interval, the x interval for which our function is positive or negative. So we actually need to find the interval. Graph the solution on the real number line and write the solution using interval notation. We do the same thing we did yesterday. You can take some shortcuts. The real number line really just is our x-axis on our graph. It means the same thing. So we're just going to use our calculator because why not? We have 2x minus 3 over x minus 3 is greater than 3. Lots of 3's in this problem. What do you want to do first? Move the 3 over. Definitely. So we have 2x minus 3 over x minus 3. And we're going to subtract the 3 because we definitely want to be set equal to 0. Because that's the point where we're going to change to either be positive or negative. A lot easier to figure out. And then what do we need to do? Common denominator. Sure, this is 3 over 1. So what do I need to multiply by to get a common denominator?
X minus 3.
X minus 3 on top and bottom. So I have a lovely common denominator now of x minus 3. And I need to distribute and combine like terms in the numerator. So 2x minus 3. What do I need to distribute? Negative 3. Mind your negative. Distribute the whole negative there. So negative 3 times x is negative 3x. And negative 3 times negative 3 is positive 9. So when I combine like terms, 2x minus 3x, negative x, and negative 3 plus 9 plus 6. So this is our lovely single fraction format. And when we're in this lovely single fraction format, it's easy to find the zeros and where we're undefined. Where do we find the zeros from? The top, the numerator. We're solving an equation. Negative x plus 6 gets set equal to 0 to find the zeros. And so it turns out that x equals 6. All right, so that's a 0, the x-intercept at 6, 0. Where does undefined come from? The denominator. That's we're saying x minus 3 is not allowed to be 0. Denominators cannot equal 0. And so we have that x cannot equal 3. And again, I'm using this notation very purposefully because when I go to graph this, I'm graphing a 6. At 6, I'm allowed to equal 0. It is equal to 0. It is an actual point. 6 for the x, 0 for the y. But if you're thinking about this rational function, what's happening when x is 3? What thing graphically happens? It's a vertical asymptote. Yeah. We are not allowed to equal 3. It is a vertical asymptote. So I'm going to use an open circle because I'm not allowed to include 3. It's not part of our graph. It's not part of anything. It's undefined there. Okay. So I'm going to use an open circle to represent that. 3 is not really there, but it's a critical point. So I'm going to go ahead and you are too going to put this function into y1. I will say that right here, when you moved that 3 over, you could also have graphed that. And should these two graphs be different? No. They are the same. All we've done mathematically here is multiply by 1. It's not going to change anything, okay? But boy, the format looks different. So it's a good way to check your algebra. Did I do my algebra correctly? If you're unsure, that's a great way to check. But hopefully, you know, with 40 heads in this room, hopefully we managed to get the right answer. All right, so I'm going to make sure I use parentheses, negative x plus 6 divided by x minus 3. And I'm going to graph that. Oh, sorry, zoom 6. Okay. And so we can see our function here. And I'm not going to, you do not have to draw the graph, but I like to. But you don't have to. So what I'm going to do, I'm going to show you, in calculus, we call this a sign chart. So we have our critical points on our real number line, our x-axis. And what we want to do is we want to test some values. So because I have it in my calculator, that's really easy to do. So I want to test an x value to the left of 3. Give me a number that's to the left of 3. 2. 2, okay. So I'm going to do trace and type in a 2. And when I type in a 2, what's my value? Negative 4. Everything to the left of 3 is going to have negative outputs. And you can see that on our graph. Everything to the left is in negative land. Okay, that's why our graph is below the axis. What's the value between 3 and 6? 4. So I'm going to trace 4. And when I plug in a 4, I get a positive 2. So between 3 and 6 are all positive values. And again, you can see that right here. We are above the axis. Everything between 3 and 6 are positive values. What's to the right of 6? 7. So we're going to try 7. And you can see we get negative 0.25. We get a negative result there. And again, everything just crosses and it's just below the axis there. So we are looking for what on this problem? What are we interested in? Greater than 0, where we are positive or above the x-axis, okay? Positive outputs happen for what interval? 3 to 6 is the interval where we have positive outputs. So 3 to 6, brackets, parentheses, what? Parentheses. I can't have a bracket at the open 3 there. It's not included, not allowed, regardless. And we don't want to include 6 because we just want to be greater than 0, not equal to 0. 6 equals 0. We don't want to include him. This is our solution interval. All the x values between 3 and 6. A sign chart, ladies and gentlemen, is literally just the pluses and minuses. You don't have to draw the graph, okay? So in calculus, we do sign charts a lot, and we'll just be looking for plus, minus, plus, that sort of thing. You don't have to draw a picture, just pluses and minuses, okay? Questions on that one? All right. One more. Oh my goodness. There we go. Letter B, 1 over x minus 3 is less than or equal to 3 over 2x plus 1. Well, what should we do first? Yes, subtract that term to the other side. So we have 1 over x minus 3 minus the whole fraction, 3 over 2x plus 1, less than or equal to 0. And then we need to do what? Common denominator. So we're going to multiply the first fraction by 2x plus 1 on top and bottom. And the second fraction by x minus 3 on top and bottom. And so we have a lovely common denominator, which I can leave in bubble form. That's most useful. And we're going to distribute and combine like terms in the numerator. So 1 times 2x plus 1 is 2x plus 1. What are we distributing for the second thing here? Negative 3 gets distributed. Negative 3x, positive 9. And so we have 2x minus 3x is negative x, and 1 plus 9 is 10. Now, here's where you really need to be using your calculator often to make sure everything is working correctly. If you don't type this in right, you're going to get a huge problem. This entire denominator needs to be in parentheses. Just the little bubbles is not enough. And your entire numerator needs to be in parentheses there. As you're graphing, before I do that, I'm going to go ahead and find the zeros and where it's undefined. Where do zeros come from? Numerator. So negative x plus 10 gets set equal to 0, which means x equals 10. Very good. Where is it undefined? From the denominator. X cannot equal 3, and x cannot equal negative 1/2. Good. Coming from the denominators. Set each bubble not equal to 0 and solve. All right, so I'm going to go ahead on my real number line and just mark these points. Let's see. I have negative 1/2. Open or close circle? Open. It's an asymptote, graphically speaking. 3, open or close circle? Open. Again, another asymptote if you're thinking about the graph. And then at 10, open or close circle? Close circle. It's equal to 0 at 10. It is the x-intercept. So I'm going to go ahead and plug that into my calculator.
Bless you.
Thanks.
Do you ever count how many times you sneeze a day?
No.
Is it a lot?
That's one so far.
It's usually a couple in class. It's okay.
Yeah.
It's the carpet. My 50-year-old disgusting carpet.
A little bit of dust in my nose.
All right.
Forgot to take my medicine today.
I'm sorry. Oh. All right. So I have my lovely little sign chart. I'm just going to use pluses and minuses. Give me a value to the left of -1/2. -2. That's what I heard first. If I plug in a -2, do I get a positive or negative result? Positive. Give me a value between -1/2 and 3. 0. That's a great value. 0 is positive or negative result? Negative result. Give me a value between 3 and 10. 6, I heard first. Because that's sitting right next to me. Positive or negative result? Positive. All right, give me a value to the right of 10. 11. Whoa, what happened? Ah! What's the problem? I have to extend my graph. Yeah, our graph. Oh, I could go to the table. That's very good. I could go to the table, and I see that at 10 we are beyond 10. We're negative land. That's a very good solution. You might also extend your window. Our window stops at 10, so I can't do anything beyond 10. Yeah, it is negative. All right. So what are we interested in? What are we trying to figure out? Less than or equal to 0, which means negative or below the x-axis. Good. All right, so where are we negative?
0.
Between -1/2 and 3 and 10 and everything to the right. Okay, so what's my integral notation? Should we use a bracket at -1/2? Parenthesis. We can't include them because they're asymptotes. Yeah, so -1/2 to 3. Union? Bracket at 10. Why a bracket? Because we're allowed to equal 0. So we want to include our 0 there. So bracket 10 to infinity. Okay? All right, ladies and gentlemen, do you have any questions for me? All right. They haven't taken us out past restriction. All right, there you go, ladies and gentlemen.
The stage like 22 minutes.